For 4 billion years, the far side of the moon hid its face from every living thing on Earth. No human eye had ever seen it. Not from the ground. Not from orbit. Not even from the Apollo missions, which grazed the near side and came home. Then, on April 6th, 2026, 4 astronauts crossed that boundary. What they photographed on the other side didn't just break records. It broke something in how we understand the moon itself. Here is what they actually saw. The moon is tidally locked to Earth. Its rotation perfectly matches its orbit, which means the same hemisphere always faces us. Always. That is not coincidence. It is gravitational mechanics working over billions of years, a slow celestial synchronization that locked the far side away before humans existed to wonder about it. When the Orion capsule crossed the Terminator line at roughly 4,000 miles above the surface, the terrain below changed so completely that even trained planetary geologists stopped and stared. The near side, you know from photographs, is dark and smooth in places, swept flat by ancient lava seas. The far side looks nothing like that. It is a completely different world. Every square kilometer is saturated with craters, overlapping, colliding, stacked on top of each other in layers that go back billions of years. The near side has these smooth, dark patches called maria, ancient lava flows that covered the damage. The far side has almost none, and that absence tells a story more important than the craters themselves. Planetary scientists believe the lunar crust on the far side is significantly thicker than on the near side. When massive asteroid impacts struck that hemisphere billions of years ago, the crust was too deep to puncture. The magma underneath never surfaced. Nothing smoothed the damage over. So what the Artemis II crew was photographing was not just a cratered landscape. It was the unedited geological record of the Late Heavy Bombardment period, an era approximately 4.1 to 3.8 billion years ago, when the inner solar system was being hammered by a wave of impactors. The far side of the moon is a frozen archive of that catastrophe, and for the first time in history, human hands were pointing cameras directly at it. What the photographs revealed at the Oriental Basin stopped researchers mid-sentence. The basin sits near the boundary between the near and far sides. It is one of the youngest large impact structures on the moon, meaning it is also one of the best preserved. The Artemis II images show enormous concentric rings radiating outward from a central impact zone. These rings did not form slowly. They formed in seconds. When the impactor struck with enough kinetic energy to temporarily liquefy solid rock, the surface material behaved like water. It rippled outward. Then it froze in place. What you are looking at in those photographs is a shock wave locked in stone from an event that happened before the first life appeared on Earth. Running across those frozen rings, you can see thin, perfectly straight lines carved into the landscape. These are crater chains, not random impacts, secondary craters. When the original impact blasted debris into the sky, those chunks of lunar bedrock came back down in lines, gouging secondary craters in near-perfect rows across the surface. The lighting conditions during the flyby amplified everything. Sunlight hit the terrain at an extreme angle, casting shadows hundreds of meters long, turning the geological texture into high-contrast topographic data visible from thousands of miles away. The crew then turned their lenses toward a crater called Vavilov, positioned near the terminator line where lunar day meets lunar night. At that boundary, the sun is nearly horizontal. The shadows are extreme. A crater wall that might look like a gentle curve at noon, instead, reveals itself as a vertical cliff face several kilometers high. What looks flat in orbital photography turns out to be a landscape of radical vertical relief. The terminator line is effectively a geological truth serum, and no human had ever photographed these specific features from this angle. Then, something unexpected showed up in the images. Small, bright white dots scattered across the dark sections of space behind the moon. They look like stars. They are not stars. The Orion capsule was operating deep outside the Earth's magnetic field, in a radiation environment that ground-based facilities cannot fully replicate. High-energy cosmic rays bombarded the camera sensors continuously. When one struck a pixel directly, it permanently overloaded it. Those white dots are dead pixels recording false light, physical casualties of a radiation environment so intense it was quietly damaging the equipment in real time. The photographs themselves carry the scars of deep space. And then the eclipse happened. Nobody planned it. It was a mathematical consequence of the launch date. If weather had pushed the liftoff by 72 hours, the orbital geometry would have shifted entirely, and the alignment would have never occurred. But it did occur. As Orion came around the far side, it flew directly into the shadow of the moon. On Earth, a total solar eclipse lasts a few minutes because the moon and sun appear roughly the same size from our vantage point. From the position of the Orion crew, the moon physically dominated their entire window. It took the sun 54 minutes to cross behind the lunar disk. 54 minutes of totality, an event that has never happened in human spaceflight history. In that window of darkness, with the overwhelming glare of the sun blocked, the cameras captured things that are almost impossible to photograph under normal conditions. The sun's corona, that vast halo of superheated plasma extending millions of miles into space, became visible around the edge of the moon. Simultaneously, Earthshine, sunlight reflected off our own planet, bounced across 250,000 miles of vacuum and faintly illuminated the lunar surface inside the shadow. You could see the texture of craters lit entirely by reflected light from Earth. The images show both phenomena simultaneously, the corona and the Earth-lit craters together in the same frame, because the geometry of that specific moment allowed it. And in the wider exposure shots, extending outward from the eclipsed moon, 3 planets appear in a diagonal line. Saturn, Mars, Venus lined up. That line is the ecliptic plane, the flat disk of the solar system, where the major planets orbit the sun. In those photographs, you can see the actual shape of the solar system, the plane we all share, rendered visually against a glowing corona, for the first time in the history of human observation from deep space. Pilot Victor Glover said over the radio that humans simply haven't evolved to process a view like that. He was right, but that statement carries more weight than it sounds. Every image these 4 astronauts captured was taken not by a robotic probe, not by a telescope, but by human hands making real-time decisions about exposure, framing, and focus. The difference in resolution and context compared to unmanned missions is measurable. The photographs look the way they do because people were there to take them. The far side of the moon didn't change when Artemis 2 flew over it. It has looked exactly like that for billions of years. What changed was us. For the first time in all of human history, we held direct visual evidence of the solar system's most violent early chapter. Not a simulation, not a reconstruction. Photographs taken by 4 people floating in a capsule above a landscape that had never been seen, while a 54-minute eclipse that no one planned painted the sky around them in corona light and earthshine. The universe was always that extraordinary. We just finally got close enough to see it.